Hey everyone, and welcome to the vets.to.coders, Part 2, Object-Oriented Programming. Today we are covering classes. So, what are classes? Classes is an object that we can create, and a class can hold many different data types, all within that specific object. A class can be anything. In this case, we're going to create an address. An address has a number, which is an integer. It has a street, which is a string. It has a city, which is a string, a state, which is a string, and a zip code, which is also a string. So that is all what we see here. So we have a class address. It is public. We have an integer number and an integer zip. We have a string street, a string city, and a string state. And we notice that when we have a class, opens with a curly brace and it ends with a curly brace and a semicolon. So it's a little trick. So there are three access specifiers. We have a public. Public, which means it can be accessed everywhere, including within the main. That's important. So public can be accessed within main. Very important. Next we have private. Private can only be accessed through its member functions and can not be accessed through main. So that may be kind of confusing right now. We'll explain what that means. As far as protected, just think of this as private for now. It comes back into it later when we talk about inheritance in a few videos. So back to classes. Created using the keyword class. That's what we see right here. And then the class name. We are calling our class address. And the convention for naming, you always want to use an uppercase letter to name your classes. So I have class address. The curly braces, that'll be what opens and closes the class. So a curly brace opens it, and then a curly brace and a semicolon closes it. So within main, you can create an object by making the type of the user-defined type that you just created. So that would be right here. So normally you'd have a return type, integer, string, bool, but now you're going to make that the user-defined type that you just created. I'm going to make that of address, of course with an uppercase A. And then whatever I want to call this specific object that I just created in this instance, what do you want to title it? I'm going to call it White House. Now, because all of these member variables are public, I can access all of them in main. So that's what we were talking about with these access specifiers. When it's public, it can be accessed within main. So within main, I'm able to access the White House number, the White House street, White House city, state, and zip. And all of those are part of this specific White House object. And of course, number, street, city, state, zip are all member variables of the address. So that is essentially what a class is. It's a way to put a whole slew of member variables and attach all those variables together with some functionality with methods and functions and encapsulate all of that into an object here. Next, we have something called a constructor. So here we create the object and we notice that there are no parameters next to our object that we create. And that's the same thing we see here. We're creating an object and there are no parameters. Right now I'm going to show you what it looks like with what's called a parameterized constructor. So I'm calling the address and I'm creating a name for it, and I'm giving a bunch of values. These are values that I'm telling it specifically what to assign to each item within the address. This is called a parameterized constructor. Right now what we're talking about is going to be a default constructor. So a default constructor just creates the object, and we're not passing in any values. I simply want to create it. The reason for a default constructor gives it so that the user has the ability to create an object this way. And what happens when they create a default constructor with no parameters, it's going to go and call this constructor here. This constructor is going to go and assign every item that we have, every variable, and it's going to give it a value. Because it's a default constructor, we want to either give it the value of 0 or give it the value of nothing. So the number gets assigned value of nothing, or of 0, zip, 0. Street, city, and state all get the value of nothing. So the reason is when this object is created, even though it has no values, we need to explicitly tell each value to be nothing. So that is the reason for the default constructor. Again, default constructor gets called when no parameters are available. This is what's called a parameterized constructor, and it is used to initialize all the values that the user chooses when the object is created. So this is in main, int main, they're creating an object called place, and they're telling, so in order, the first thing they're passing in is int n gets assigned to number, so the first thing they're passing in is the number. The next thing they're passing in is string s. S is the street. So the second parameter they're passing in is a avenue. The third parameter they're passing in, string c, is going to be the city. So it's assigned c to city. So we have 1, A Avenue, the city of B. The next is going to be the state, and the last parameter is going to be the zip code. So that would be the address. Inside the parameterized constructor, they are assigning all the values. Again, that's how we get some help, and now we're going to jump over to our code. So first we want to include our libraries, include IOStream using namespace standard. Okay, now we're going to create a class, and we are going to create an an address class. So class address, and let's put all of this inside of our address. So first, let's create everything that needs to be private. Everything that needs to be private is going to be our member variables. And as we just said, for an address, our member variables are int, number, and zip. And then for string, we had street, we had state, and we had city, state. There we go. Next, everything that is going to be, whoops, this should say public. Everything is going to be public. So that's what we have that's going to be private. And the reason why those are going to be private is we want to make sure that those are all protected and encapsulated. We don't want any of these to be adjusted that is not intended to be adjusted, which is what's called encapsulation. So the idea of keeping things private and public is the idea of encapsulation. So next thing we want to do is we want to create things that are public. So we're going to create a function. This is a little bit unconventional, but nonetheless we're going to do it. Create a function to load all the data. So we'll call it void load data. It's going to take no parameters. And what it's going to do, I could, of course, have it just take parameters and it can act kind of like a constructor, or it can act like a setter. But instead, I'm just going to have it ask a slew of questions, and it's going to one by one fill in all the answers. So it's going to ask cout, enter street name. And because I don't want to take up a whole bunch of space, I'm going to just put it here, get line, and I'm going to cin, and I'm going to cin to street. Cool. Next is going to be cout, enter house number, get line, cin, and this is going to be the number. Cout, enter city, get line, cin, city, and next cout, enter city, state, and then do the same thing for the zip. Enter zip. And because it's an integer, we'll just do cin zip. And yeah, we gotta do that up here too. Cin number, and whenever we go from cin to get line, we need to use a cin.ignore. So I think we are good. We are asking for all the data. We are loading all the data. I think we are good. And let's just do one more cn in case. Cn ignore here. Just in case I wanted to come back around to call this multiple times, we have the options of doing that. Next, let's just do another printing. So do a void print addy. Takes no parameters, and then we're just going to print everything. So the way you read an address is the number. So cout number. Whoops. Street. I think we should probably put a space in there, and then we do the street. And then we need another space in there. And the city. And then we'll put another comma. And then the state. Oops. And then I think after the state, you want to do a period for before your zip. And we'll come back and most likely have to edit that. Okay, so that works. So then we have our member functions, which is this. These are our member functions. Awesome. Now we can get into our main. So that should be everything. And of course I can come in here and I can create a constructor, which would be a good idea to come in and create a constructor for the address. But you know what? We'll save that for a different video. So we'll just go into the int main and copy this and put it in. And now we want to create the object. So address. And now we want to create the object with, what do we want to call it? We'll just call it addy. And we'll call the object functions. So we'll go addy dot load data, and then we'll do addy dot print. So, oh, and then yeah, return 0, of course. So we have our address. So we have address load data. So it's going to call this function, and then it's going to ask us all this information. And every time it asks for our information for a specific item, it's going to save it into that specific address regarding that object. So when it calls this function here, when we make that call there, this call here is going to then call this function, and all the information that we input is going to be saved to this specific object that we're calling it on, which is the addy object. And if I were to call this repeatedly, like if I were to have an array of addresses, I could call this repeatedly, all on different locations. Like, so for instance, I could do this. I did not mean to do that. Addy of 3. Now I have a array of addresses, and of course we're calling them addy, but this created an array of 3 different addresses. So I could, if I wanted to, make this index 0 and make this index 0. And just like that, I have my arrays, and now I'm here talking to specific indexes, but that was not our goal. I just want to show you that you can do other things with your address. So let's run this. So let's save it, build it, and let's run it. So enter street name, do Elm Street, house number, 100, city, state, CA, zip, 100 Elm Street. Okay, well, yeah, shouldn't be a comma after the street. So 100 Elm Street, California, Okay, let's do that one more time, but let's fix it. I do not want to put a comma after the street. So let's save it and let's run it one more time. So build, run, enter street name, Elm Street, house number 100, city, state, CA, 100 Elm Street, city, California. Cool. So created it, and we have an X value of 0. Everything was successful. So here is the beginner of the address. So kind of a little intimidating in the beginning, but if you start breaking things down piece by piece, it's not too complex of a problem. I hope this makes sense, and we will spend the next couple videos extending classes a lot. So getting more in depth with different classes and doing different things. Cool. Thank you.